So in this question, we want to solve the linear Diophantine equation ax plus 12y equal to 20. Now, to solve this question, we want to start by finding the greatest common divisor between 8 and 12. Now, to find the greatest common divisor, we know we have to start with the bigger number, which is 12 here, and work out how many times 8 goes into 12. Now, we know that 8 goes into 12 once, with a remainder of 4. So we can write this as 12 equals 8 times 1 plus 4. Now, to continue this process, we bring down the 8 to the front position, and we bring down our remainder, which is 4, down into this position here. Then we want to find out how many times 8 goes into 4, and we know that 4 goes into 8 twice with no remainder. Now, this is really important that there's no remainder because we can stop the process. Now, to find the greatest common divisor from this, we look at the number in this position, which we know should also be the remainder in the line before. So the greatest common divisor between 8 and 12 is 4. Now, what we want to do next is to find out if a solution exists to this Diophantine equation. To do that, what we want to do is we want to divide our value for c, which is 20, in this case by our greatest common divisor. So if we divide 20 by 4, we get 5. Now, because this gives us a whole number, then this means that this Diophantine equation has a solution. So now that we know that this equation has a solution, we want to express our greatest common divisor as a linear combination of 8 and 12. To do that, we start again with our second last row, and we rearrange this so that we've got 4 on its own. So if I go down here, you can see that I do that, and I take the 1 minus 8 across to the other side, and I'm left with 4 equals to 1 lot of 12 minus 1 lot of 8. Now, to find my initial conditions for x and y, what I want to do is to multiply this line by my value for k. So that means I want to multiply this line by 5. If I do that, I will get 20, which is equal to 5 lots of 12 minus 5 lots of 8. Remember from before, when I'm doing a linear combination, I'm not multiplying 12 and 8, I'm multiplying the coefficient of each. This is to ensure that I get an equation in the form which is similar to the Diophantine equation that I started with. So once I've done that, I can read off from the equation what my initial values are for x and y. So my initial value for x is minus 5, and my initial value for y is positive 5. Now that I've found my initial condition for x and y, what I want to do is go on and find my general solution for each. Now, to do that, I need to use the formula, which is xn, which equals to x naught, which is my initial condition for x, plus b over d times n. D is my greatest common divisor, and b is the number in front of y. Be careful when I'm finding x, I'm using the number in front of y. Similar for finding y, it's yn equals y naught, which is my initial solution for y, minus a over d times n. Again, d is my greatest common divisor. A this time is the number that is in front of x in my equation. Again, be careful when I'm finding y, I'm using the number that's in front of x. So to find my general solutions, starting with finding x, I sub into the formula, so I use minus 5, which is my initial condition for x, plus 12 over 4, times n, which means my initial and general solution for x is minus 5 plus 3n. My general solution for y, subbing in to the formula, is 5 minus 8 over 4 times n, which gives me 5 minus 2n. This means that I can use these formulas to find many more solutions for x and y, which satisfy my Diophantine equation ax plus 12y equal to 20. To show you how to do that, if I set n equal to 1, so to find the first solution, I would sub in 1 into each of my general solutions where n is. So if I do that, to find x1, I would then have minus 5 plus 3 times 1, which if I tidy up gives me minus 5 plus 3, which is equal to minus 2. If I sub in 1 into y, I would have 5 minus 2 times 1, which gives me 5 minus 2, which is 3. So this means that when x is minus 2 and y is 3, then that is also a solution to ax plus 12y equal to 20. So the complete solution for the Diophantine equation, what I do is I sub each general equation for x and y into the Diophantine equation ax plus 12y equal to 20. So if I do that, that gives me 8 times minus 5 plus 3n plus 5 minus 2n equal to 20.